Hi guys, welcome back to my channel, and this is the day 14 of DSA bootcamp, and I will be starting with lead code problem. And today morning I have been explaining the GFG problem. If you still not watch my video, please watch it. I will be linking in the card section where I have been explained everything like dry run and subsequences, subarray water and subset infusion and their explanation. Everything has been explained. And now coming to the lead code problem, let's go to the portal. Here you can see the lead code problem, and my daily streak was 843. And please support us. And I was seeing uh, some criticizers, even if you have some talent or some good at DS or some other whatever the skills you have, please comment out in this session so that we'll learn each other, or we'll got to know how much level you are going at. And do not criticize and dislike the video. It's not a weird, because of I'm taking efforts and making videos every day. If you want to learn something, please do that. Please watch it. Or if you don't want, you can skip it. But don't criticize that the karma, right? It will reflect to you as well. Do not do for other such kind of activities. Not for me, even for others, whatever. That kind of approach or kind of mindset doesn't work in the long run. You were surviving, but that's it will be not survive for the long run. Okay, yeah. Now going into the question itself, build a matrix with a condition. What question states that here there will be one row condition matrix, two-dimensional, and column condition matrices, and there will be one K, and we have to build a matrix such that row condition should be matched and column condition should be satisfied. If both the conditions are satisfied, we can able to build a matrix, and we have to return that matrix that satisfy both the conditions. So if there is no answer satisfying both the conditions, then we can return an empty matrix. That's what the question. I simply simplified for you in a layman terms. And yeah, we can see some dry runs to get a better understanding of the question. And row conditions, the first element, first row indicate 1 and 2, which means that in the row condition says that whatever the elements comes before, it should comes before the row of the second element, which means that one should come upper row and two should come at the lower row. And same thing for the second element, second row also. For three should come before and two should come below the row. Three should come at the upper row, and two should come at the below row, lower row. And this is for the column conditions, which states that columns are ideally like this, in this fashion, vertical fashion. So uh, we should look at the first element 2 comma 1. This states that whatever row 2, that should have the left column, and then one should add the after column, which means right column. As you can see, 2 at the left column and 1 will be the right column. Same thing will be followed for the 3 and 2. 3 should add the left column and 2 should add the right column. 3 should add left column and 2 add the right column. So this is how the given row condition and column conditions are satisfied, and we are returning that particular two-dimensional matrix. That's what the question states. Same thing can be followed for this. This is unable to create build a matrix, so we can return an empty. That's what the interviewer expecting. And K was ranging from the 2 to 400. These are the constraints, which is very important while building an algorithm and while communicating in an interview, or how much percentage of optimization you can able to do that, and what kind of a category it falls under. Those factors are more important, and it comes from experience only. And yeah, and row length, it will be ranges from the 1 to 10 power 4, and row dot length by particular row matrix dot length will be equivalent to the column length, which means that at any test case, we have only two elements in the individual row. That's what this condition says. Okay, and you know, right? Row length means Number of rows will be 1 into 10, ranges from 1 to 10 power 4. Same for the columns as well. And above left, I whatever the indices that will be ranges from 1 to k, and both are not equal as it says, which means that auxiliary number of above index and below index number of things, which means that elements, above element and below element, how many will be differ. It was not unique, not same. And let's go to the notepad to get better understanding. This question was asked in Apple twice and Google in the last couple of years. Okay, and same question will be taken, and I will be using Kahn's approach because of, as we can see, we are basically following some pattern, which means something before than this. So we are using some kind of an ordering. If you identify clearly, we are making an order, which means that while building in matrix, we can simply arrange them. So that's the reason ordering is matter here. So when it comes to ordering, what will be your algorithm comes into mind? It's nothing but a Kahn's algorithm, because topological sort uses cons only, is nothing but a cons. So how it works is that by keep track of number of incoming edges for each node, which means nothing but an in degrees we are counting, and we are using Q and Q based algorithm, so that every time we encountered zero index in degree nodes, those are taken and those edges will be removed, so that in degree will be reduced on the overall. For example, here you can see that I have taken one test case, about test case only, k equal to 3 and RC equal to the row condition indicates, column condition indicates CC. Okay, I'm doing topological sort on the row condition, which means this row I was doing topological sort. How it forms? It simply forms that the first node will having direct indirect edge to the 2, and 3 having indirect edge to the 2. So as you can see, in degree for 2, node 2 is the 2. We have two occurrences. Two edges are coming from which have the incoming edges for the 2. For 1, there is no incoming edge. There is outgoing edge. And for 3, there is an outgoing edge. So we mark as 0. In degrees are 0. And for this, only 2. And as per the algorithm states, you can see we are making an integers and we are initializing every adjacent list, and then we are calculating the integers for everything, and we are checking, we are storing all the 0 degrees integers to the queue, which means that here we are having in degree of 0 for 1 and for 3. So we are storing into the queue. As you can see in the first iteration, we are storing all the in degrees 0, those with respect to nodes. So after storing that, you can see here, after storing, we are popping out the first element 3, we are popping out 3, and we are removing this edge. Let me make this highlighter so that you can able to see visual as we are removing this edge, so that this will be reduced to 1 for the popping out for 3. After that, in the second iteration, we are popping out for the 1 also, and we are removing this edge, so this will be reduced 1 to 0. As you can see, for the node 2, in degree will be 0, so that we can add this into our list. So here you can see that initially we are storing all the in degrees while initializing Q. That is the first case, and this is where the loop starts from, and we are popping the first element, and we are uh, orders are increasing. And we are reducing the count itself. Here you can see we are reducing the in degree of the particular adjacent element, and when we encounter 0, we are simply storing into our queue, and this will be followed and until it the queue got empty. Okay, after doing this, we will get one resultant ordered topological sort for this row condition, which is nothing but 3 1 2, which indicates uh, that 3 is point to having an outer edge to the 1 has an outer edge to the 2. So the ordering will matters. Ordered for the rows will be representing this, and same thing followed for the column column conditions as well. As we given the column condition we are taking, and you are using the same, and we are building a graph. After building a graph, we are taking the number of integers. As you can see, there is one integer coming from 2, and here also we are having one integer. So we are storing the initially 0 degrees, which is nothing but a q 3, and we are popping out and deleting this now. Sorry, you can see that green indicates the second iteration. We are deleting this edge and reducing the integer. So this is also eligible for inserting. We are added to the queue too, and for the third iteration, the blue ones, we are deleting this no edge, and this will be resultant to 0. So this can be added to our queue. After that, we will be getting a resultant ordered topological sort for the column conditions. So these are the ordered. So at the end, we are getting two topological sorts for row and columns. So with the help of the ordered conditions, we have to build such matrices, two-dimensional matrices. So we are taking two-dimensional matrices of k size, k into k. As you can see, k into k we are taking, and in this k is nothing but 3, right? So we are taking 3 by 3 matrices, and after taking that, the first element, the matrix of the first row index will be pointing to the element value. Whatever the ordered value of the first index should be at the particular position. And same thing for followed for the three also. So initially the first index 0 0 will be pointing having the same value, so we can store here itself. And after that we are getting 1 and 2, which means that row 1 and column 2, which means this cell should be filled with the 1. This cell should be filled at 1. And same thing for followed for the 2 and 1. We are filling the second row, the first column will be filled with 2, as you can see above. Let's go to the code itself to get a better understanding. This is the question given: building matrix and row condition is given, column condition is given. We are doing topological sort. We should go to the topological sort. Basically, these are the graph, indicate the graph, nothing but an array of list. Each array contains respect to list, adjacent to list we have. So adjacent list, we are initializing the array list, and then we are performing degrees, calculating in degrees, and the order where we have to place that element, like how we are getting this ordered topological sort. That's the reason we are using BFS, breadth versus Q. With the help of Q, initially, we are going all the edges and marking respect to U is pointing to V, which means U having an edge of this. So we are adding to our graph and we are incrementing the in degree out of it only for the first this occurrences, because in degree is pointing towards this one, right? U is pointing towards V. So we have an incoming edge. So that's the reason we are adding to the V only. X1 indicates the second component. We are adding that as an indicator. So it has an indicator. Array is pointing to U is pointing to V. Okay, that's why we are adding. After that, we are adding all the 0 in degrees to the queue initially, and then we have started BFS approach, and we are pulling out the first element in the queue, and we are storing in our order. Order is nothing but ordered topological sorting for the particular conditions. That's the reason this is the index where we have to place. Index is starting from 0, so we are started from 3. As you can see, first initially 3 will be there. 3 will be stored at 0. Index is 0. As you can see, index is initially 0, and we are incrementing here. So it will start from filling from 0 to up to the size of a row, ordered row, and 3 will be stored. The first element is 3, and FIFO order, first in first out. 3 will be stored at 0, and 1 will be stored at 1. 2 will be stored at 2. So 3 1 2. That's how it was formed. And here we are decrementing the count. Why? Because how many levels we have to perform. We should not perform until it's complete. So uh, we have to check that condition. So if we have reached out the number of levels, and here we are checking, exploring all the edges, adjacent list, all the we are decrementing the in degrees, and when we got zero, we are adding into the queue, and we are checking if it is not a zero. At the end, if it is again still we have 0, then we can return an empty array, which means that if we found in cycle deduction also very important. Suppose if we have like this matrix, all are pointing to themselves, so it forms in cycle form, and then there will be infinity recursion calls. Loops will not terminate until stack overflow exhausted, heap size exhausted. So that's the reason we need to detect a cycle with the help of number of iterations we are taking. We should take number of rows we have, that many iterations we are taking. So that's the reason we are checking. At the end, if n is not equal to 0, which means cycle exists, we simply return there is no order. Then we can return that, so that empty array will be returned, empty collection will be written, or else there is no cycle formed in our graph, so we can return an ordered matrix. Once we got the ordered rows, which means this ordered rows, and ordered columns, we got this in our stored here. After that, we are performing the conditions. If having nothing present inside that, we can simply return the two-dimensional array, which means that cycle. This is for cycle condition. This is the cycle exists. If there is no cycle, we can build a matrix by constructing this. Simply, we are going for the respective indices starting from I00 and column 0. If we have the same element, we are storing the particular element itself, ordered index of I. Nothing but ordered index of I is nothing but 3. If we have the both are same value, ordered index of 0 indexes, we can simply store that index. And we are checking for the other conditions also. Like this, when we complete all the elements, like here 1 1, right? If we check the order index of 1 and order index of column index of j is nothing but it will check for twice, k times. So when we got that, here it will occur at 1 comma 2, which means first row column 2, this will be entered because of we are iterating the twice. So the this element will be stored, the ordered element. Here we are storing row index condition. We are storing here, and at the end of column we are iterating. We are using two loops up to the k side, which means we are multiplying k into k. We are using that, and on the second iteration we found that particular element was matching, and here you can see, right? This is for I row, I for 1 and j for 2. So we are matching 1 1 at one index and second column, j equal to 2. So that's the reason we are storing that particular index. Even we can store ordered column also. This one also, that will suffice, because we are using brute force for finding whether one was exist in the ordered column or not. If one was exist in the ordered column, then we can find that match. We found the match at the particular row index of 1 and column index of 2. So that's the reason we are find out match, and we are storing that particular 2. And 2 was found at the row index of 2, row index of 2 and column index of 1. So column index of 1 here 2. So we can store any one of those as we are matching. If you got a match of 2, simply store at their indexes. I is pointing at the respective 2's location, and yes at the one location, because this is the indexes of the ordered arrays. So that's the reason we formed for I2 and J1, the 2 should be placed over. So we are building that matrix with the help of brute force for the k into k, and we are returning that. So the time complexity is At max, we are doing k into k, brute force approach, k square at max, and 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 also we are checking for the length of an the particular edges. Also, we are checking basically. So it will be the max of k square, comma, and whatever the value max, that will be our time complexity. Space also same, because we are storing matrices, and also we are storing the respect to adjacent graph also. That is an auxiliary space we are taking. So that is the max of k square, comma, n. That is the space and time complexity of this algorithm. Hope you got it. Please watch it clearly, because I have written the examples how it forms topological sort and cycle detection also. We are taking number of times, how many elements are there, number of iterations only we are taking, and if it is again we left over with even iterations was left over, we can't able to solve, then the cycle was exist, we are returning the empty array here, and whenever we got an empty array, which means cycle was found in our graph, simply return that empty collection, which means empty two-dimensional array. There is no possibility of building in matrix, else we are forming an we are building in graph. Here we are learning two things. One is topological sort, how we are ordering the matters, and second thing, cycle deduction in the graph. We are making an directed graph. As you can see, we are building a directed graph with help of u is pointing to v, which indicates we are calculating all the indices, incoming indices, and we are storing into the zero. If incoming is zero, we are storing to the graph, and BFS is followed. So cycle detection also we are keep tracking inside the our topological sort. This is the standard topological sort. This is where the building our matrices with the help of topological sort and cycle detection program. That is main intuition of the Kahn's algorithm. Hope you enjoyed it, and please like, share, and subscribe.